everyone. Today we will see the functional pin diagram of 80386. We know the basic difference between the 8086 and 80386 microprocessor. In 80386, whatever flag register, whatever control register, what are the number of registers we have, all are having the size of 32 bit. While for the 8086, the size of register is the 16 bit. Now we will see the functional pin diagram of 80386 microprocessor. See, address bus and the data bus. Both are having the size of 32 bit. Here address bus is of from A2 to A31. Then byte enable signal is available for the 80386 to select the memory bank of the 80386. 4 memory banks are available in the 80386, and to which bank we require, depending upon that we have to send the signal either on B0 or on B1 or on B2 or on B3. Byte enable. This BE stand for the byte enable, and all these 4 lines are active low. B0 byte enable 0 pin. Byte means what? 8 bit. And as these are the from B0 to B3, we have the 4 pins. That's why this size is of 32 bit. Along with that, we have the data bus, which is of bidirectional 32 bit. Now we will see one by one pin diagram, pins of the 80386. Majorly, all these pin diagrams are classified into these 6 types. First is nothing but the bus memory interface unit. Either data or address bus be required or the control bus be required. Next is the code prefetch unit, then instruction decode unit, execution unit, segmentation unit, and the paging unit. Remember, in 8086 microprocessor, paging is not available, but this is the advanced feature of 80386 in that we are having the paging concept. Then see first signal, first pin, which is nothing but the WR hash. Hash means what? Bar. WR bar. W is write, which is active high signal, and R hash or the R bar is nothing but the low signal, active low signal. If we have to write the data, in that case we have to send high signal on this pin. If we have to read the data from the memory, at that time we have to send the low signal. Next pin is the DC bar. D stand for data, C stand for the control. If we have to access that pin as the data line or the control pin, according to that we have to either send 0 or the 1. Next is the memory input output. Here memory is the active high signal and input output is nothing but the active low signal. Means what? This pin simply differentiate between the memory and input output cycle. Next pin is the lock bar. In some book there is a hash is given, in some book bar is given. Hash and bar meaning is same, means what? These are the nothing but the active low signal. This lock bar output pin enables CPU to prevent the bus which is used by the another signal. Next is the next address input pin, which is again active low pin, which is required for the pipeline. Next is the ADS bar, which is stand for the address stroke or the address state pin, which is again the active low pin. Then next is the ready pin. Ready low. When we are going to send low signal on this pin, means what? Our bus is ready for the next cycle. Then VCC and VSS for the supply lines pin. Next, error. When there is a 0 on this line, means what? Some error is encountered into that chip. Then next signal is pre-request. This is the processor extension request output signal. Next pin is nothing but the interrupt, which is stand for the maskable interrupt, which is active high. Then next pin is NMI, which is non-maskable interrupt, which is of type 2 interrupt pin. All these These are nothing but the input and output pin of 80386.